This is Mrs. Zappia with Lesson 16, Methods for Selecting a Random Sample. Student outcomes for this lesson. Students select a random sample from a population. Given a description of a population, students design a plan for selecting a random sample from that population. In this lesson, students will use random numbers to select a random sample. Unlike the previous lessons where students selected at random from a physical population, in this lesson, the random selection will be based on using random numbers to identify the specific individuals in the population that should be included in the sample. To generate a set of random numbers, you may use this website or another one. Pause the video and write the essential question. When looking at a sample of data, what are some clues that it may not have been randomly selected? Example 1, sampling children's books. What is the longest book you have ever read? The Hobbit has 95,022 words, and The Cat in the Hat has 830 words. Popular books vary in the number of words they have, not just the number of different words, but the total number of words. The table below shows the total number of words in some of those books. The histogram displays the total number of words in 150 best-selling children's books with fewer than 100,000 words. The histogram is on the next page. Take a look through the list of titles and see if there are any books that you are familiar with. Question 1. From the table, choose 2 books with which you are familiar and describe their location in the data distribution shown in the histogram above. You can choose 2 books if you would like to. The 2 books that I am using are Black Beauty and Cat in the Hat. So I'm going to go back to the previous page and look for Black Beauty. Black Beauty is right here, and it has 59,635 words. The Cat in the Hat. The Cat in the Hat from the previous page said that there were 830 words, and so that would be in the first interval. Black Beauty is in the interval of 55,000 to 60,000 words, which is over here, and The Cat in the Hat is in the first interval of 0 to 5,000 words. Put dots on the number line that you think would represent a random sample of size 10 from the number of words distribution. So instead of drawing 10 random samples, we are going to just think, if we had a sample of 10 books, what would the number of pages be like? Look at the histogram and see how the data is distributed. And notice in the first interval that that is the tallest. So I would expect in my sample of 10 that there would be at least 1 in that interval, maybe even 2. Then I notice that there are more books in the lower intervals of, say, less than 20,000. So I'm going to put another one over there. Then I notice over here that there are quite a few in this group of 85,000 to 95,000. So I think that there will be another book chosen in that area over there. And it said to choose a random sample of size 10. So I need 10 data dots. I think that there would probably be another book chosen that has about that many number of pages, and maybe one over here and in the middle, and maybe another one over here. Let's see about how many that is now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need one more. And I think, where should I put it? Where is most of the data distributed? I think that there are more books with page numbers in this area than they are in the middle. So I'm not going to add another one to the middle, but I might add it more to this side. So I'll go ahead and put another one over here. So notice that my data distribution is similar to that of the histogram. Example 2. The histogram indicates the difference in the number of words in the collection of 150 books. How many words are typical for a best-selling children's book? Answering this question would involve collecting data, and there would be variability in the data. This makes the question a statistical question. That's a good thing to know. Would you highlight that or note that? What makes it a statistical question? It involves collecting data, and there would be a variability in the data. That's what makes it a statistical question. Think about the 150 books used to create the histogram above as a population. How would you go about collecting data to determine the typical number of words for the books in this population? You want to find the mean, and that is the average number of words per book. You do that by adding all of the words in all of the books, and then you divide by 150 books. Or you could make a dot plot of all of the words in each book, and then find the median. So you could either find the mean or you could find the median in those two ways. How would you choose a random sample from the collection of 150 books discussed in this lesson? We could make 150 slips of paper that contain the names of the books, put them in a bag, and select 10 or 15 books. The number of pages of the books selected would be my sample. Or you could use a random number generator, where instead of pulling numbers out of a bag, the generator selects the numbers to use the sample. Remember that the purpose of this lesson is to select a set of random data using random numbers. So let's go over how to do that. How to use 10 numbers selected from a bag that contains the numbers 1 to 150 to select books for the sample. Consider the following random numbers obtained by drawing slips from a bag that contain the numbers 1 to 150. We use the numbers 1 to 150 because there are 150 titles, and we want to know how many pages are on each book. And we only want to select 10 of those books to choose from, but we want them selected randomly. So we select from the bag 10 random numbers, and there they are listed. Then you'll want to order the random numbers to make finding how many pages each book has easier to find. So we order the numbers from lowest to highest. Then we count from left to right across the first row of the list of the number of words, and down to the second row, and so on. The data for the number of words in the 150 best-selling children's books are listed below. Select a random sample of the number of words for 10 books. Okay, so these are the numbers that we selected. So the number 1 refers to the first book. So books 1 through 10 are in this column. Then the next book will be the 38th book. The 38th book would be in this row, 31 to 40. Then the 50th book, that would be in this row all the way over here. This would be book 50, 41, 42, 43, etc. The sample would consist of the first element in the list, the 38th, the 50th, and so on. The random number 1 identifies the first children's book, which has how many words. So we find the first book, and there it is. It has 59,635 words. What number of words corresponds to the book identified by the random number 38? So here we have books 31 through 40 are in this row. Book 31, 32, 33, 34, 35, 36, 37, and 38. The 38th children's book listed has 3,252 words. The data for the number of words in the 150 best-selling children's books are listed below. Select a random sample of the number of words for 10 books. You could also use a website to generate a set of random numbers. Here's one such website. This is called Rossmann Chance Applet Collection.
To generate a set of random numbers, the number of replications. If you only want one set of numbers, you leave this at 1. Let's say we want 10 numbers, and we have 150 books. So we will say from 1 to 150. And we want with replacement, which means leave the numbers back in the bag after you write them down. We want the results sorted because it will be easier to find the book afterwards. Generate, and there's our set of random numbers. If you want more sets of random numbers, you want several samples, you can change this number of replications. I would like 4 sets of random numbers, and then generate. And there are my 4 sets of random numbers from 1 to 150.
So now I've generated a set of random numbers, and we're going to find the number of words that correspond to each book identified by the random numbers. The random numbers that we generated are listed here. You want to pause the video and then order the numbers from least to greatest. A good idea is to read through the list and first find the lowest number. I notice that the lowest number is 25. Then I'm going to highlight all the numbers that are less than 100, and then I'm going to start with putting those in order. The numbers in order are 25, 46, 48, 69, 93, 117, 119, 123, 135, and 147. The next thing that we want to do is find the number of words that correspond to those books. So let's start with the first book, which is the 25th book. So we find the 25th book, which would be in this row over here, and there is the book that we're looking for, 80,798. Then for the 46th book, the 46th book will be in this row. This will be 41, 42, 43, 44, 45, and 46. 22,476. Pause the video and find the number of pages that corresponds to each of those numbers. Now check to make sure that you've got those all correct. So what we did there is we generated random numbers, and then we looked at the books that corresponded to those numbers and wrote down how many pages those books have. That is a random sample. Choose 2 more random samples of size 10 from the data and make a dot plot of each of those samples. So these are the numbers from our first sample. 80,798 pages, 3,101. So what we want to do is we want to make a dot plot of these page numbers, and then take 2 more random samples and put those on a dot plot as well. So first let's go ahead and put these on a dot plot. We have between 0 and 20,000, a dot here, here, and here. So go ahead and place these dots on your dot plot. And that is the total number of words from our sample of the 10 numbers we generated as a class. Now, sample 2 looks like this. Go ahead and draw those dots as well. And sample 3. Now when you've got all of your dots on your dot plot, we'll go on to the next question. If your teacher randomly chooses 10 books from your summer vacation reading list, would you be likely to get many books with a lot of words? Explain your thinking using statistical terms. Well, first you want to think, what is a lot of words? A lot of words to you might mean 500 words. So let's use this comparing from 0 being few words, and anything up at the upper range over here as being a lot of words. 10 books out of 150 books is about 7%. 10 divided by 150 is 7%. From the samples taken, I see that about half of the books have more than 50,000 words. about half of the books. Now, where did I get that? About half of the books, that would be, if I say about half of the dots are on the left side of the chart and half of the dots are on the right side of the chart. So about half of the books have more than 50,000 words. So I would expect that about half of the books chosen for the reading list would have 50,000 words or more. Based on the maximum in each sample. So the maximum is the number that is over here. The maximum for the sample 1, the maximum for sample 2, and the maximum for sample 3. So the maximum is at or close to 90,000 words. So I would expect one or more books on the reading list to have 90,000 pages or more. Therefore, I think that about half of the books will have a lot of pages. If you were to compare your sample to your classmates' samples, do you think your answer to exercise 5 would change? Why or why not? The sample is small, so the samples probably vary a lot. However, the distribution should be similar. That is to say, about half of the books chosen would be over 50,000 pages, with at least about one with 90,000 pages. Therefore, I think my answer would be the same. Exercises 7 through 9. This is a statistical study of balance and grade. So this next section focuses on making a random sample and designing the study. Question 7. Is the following question a statistical question? Okay, a statistical question. Remember, we went over that on the first page or two. How do you know if it's statistical or not? You might want to review that. Do 8th graders or 7th graders tend to have better balance? Why or why not? Okay, so the question is it a statistical question, and how do you know? Yes, this is a statistical question because it would be answered by collecting data on balance, and there would be variability in the data collected. It would be important to think about how balance will be measured. Berthio's class decided to measure balance by finding out how long people stand on one foot. How would you rephrase the question above to create a statistical question using the definition of balance? And explain your reasoning. Can 7th graders balance on one foot longer than 8th graders? This is a statistical question because the data will show some variability because you are timing how long they can stand on one foot. Question B. What should the class think about to be consistent in how they collect data if they actually have people stand on one foot and measure time? Should the people have their shoes on or off? Well, generally you can balance longer if you have your shoes on, but what if they all have different types of shoes, like sandals or tennis shoes or high-heeled shoes? So should they have their shoes on or off? Then should everybody do it on their left foot, their right foot, or can they choose? And how will you measure time? Question 9. Work with your class to devise a plan to select a random sample of 8th graders and random sample of 7th graders to measure their balance using Berthio's method. Now we changed this to 8th and 7th graders because our school has 8th and 7th graders, so it will be easier to collect data. Question 8. What is the population? The population is all 7th graders and 8th graders at Abbott, approximately 250 per grade level. How will the samples be selected from the population? For each grade level, first we'll number the students. Then we'll use a website to generate a random sample of 25 students from each grade level. This will be 10%. The samples need to be random so that they accurately represent the population. Question B. How would you conduct the activity? First, stand as long as you can using whichever foot you choose. Without shoes, with your eyes open, and using nothing to balance. We'll time the students to the nearest second using stopwatches from the science class. Students do the activity one at a time out in the hall so they cannot see each other. Question C. What sample statistics will you calculate and how will you display and analyze the data? The sample statistics will be the mean time in seconds standing on one foot for the 8th graders and for the 7th graders. We will make a dot plot of the times for the 8th graders and for the 7th graders using parallel number lines with the same scale. What would you accept as evidence that there actually is a difference in how long 8th graders can stand on one foot compared to 7th graders? We'll compare the shape, the center, and the spread of the sample distributions of times for the 8th graders and do the same for 7th graders. In this lesson, you collected data on total number of words by selecting a random sample of children's books. You also observed that several different samples of the same size has some characteristics in common with each other and with the population. In the second activity, you designed a statistical study. First, you considered a statistical question. Can 7th or 8th graders balance longer on one foot? Then you went through the statistical process beginning with the question and then thinking about how to choose a random sample, how students would take part, what data you would collect to answer the question, and how you would display and analyze the data. It's important to choose a random sample when you are collecting data because if you do not have a random sample, your sample may not reflect the population and therefore would not offer accurate information about the population. Some ways you can determine if a sample was not chosen randomly are: the sample is not consistent with the population. The sample doesn't have the same characteristics as the population. The distribution in the sample is quite different than the population. The sample lies outside the population. That is our lesson summary for Lesson 16.